Most people believe water is the purest act of self-care, a clear glass. Clean conscience, a daily ritual we rarely question. But biology is rarely impressed by rituals alone. Inside your skin, your joints, your connective tissue, water does not work in isolation. Collagen, the very protein that keeps skin firm, elastic, and smooth, is not built by hydration alone. Today, I want to challenge a quiet assumption and invite you into a deeper understanding of how water becomes truly useful to the aging human body when it carries the right molecular companions. Asterisk, this content is for educational and informational purposes only and is not intended as medical advice. Individual nutritional needs vary based on health status, medications, and existing conditions. Always consult a qualified healthcare professional before making changes to your diet, supplementation, or hydration practices, especially if you have underlying medical conditions. Asterisk, collagen is often spoken about as if it were a surface-level concern, something applied rather than constructed, yet in the body, it is a deeply organized structural system, a living framework that gives skin its tension, its rebound, its quiet resilience against gravity and time, and every molecule of collagen begins its life not in the mirror but inside the cell, where chemistry decides whether firmness will be preserved or slowly surrendered. Fibroblasts. The cells that weave collagen fibers do not simply need water as volume. They need water as a carrier, a solvent that delivers precise biochemical instructions. Vitamin C is one of those instructions, a molecular switch that activates enzymes responsible for stabilizing collagen's triple helix structure. And without this activation, collagen strands form loosely, degrade faster, and fail to integrate into strong connective tissue. This means hydration without vitamin C is incomplete hydration, a process that quenches thirst but does not nourish structure. Inside the endoplasmic reticulum of fibroblasts, proline and lysine residues must be hydroxylated, a reaction entirely dependent on vitamin C availability. And when this step is impaired, the collagen produced is weaker, more fragile, and biologically short-lived. Over time, this microscopic inefficiency becomes visible as thinning skin, fine lines, and loss of elasticity. Not because the body forgot how to make collagen, but because it lacked the biochemical permission to do it correctly. Plain water, while essential, carries no instruction set. It hydrates plasma, but does not guide synthesis. When water is paired with vitamin C-rich additions such as citrus, cerola, or plant-based infusions, it becomes a delivery system rather than a passive fluid. This subtle shift changes how hydration interacts with tissue remodeling, allowing water to participate in construction rather than simple circulation. Aging skin is often blamed on declining collagen production, but more accurately, it is the result of declining collagen quality, a distinction that matters deeply. The body continues to produce collagen well into later life. But without adequate cofactors, the fibers become disorganized, brittle, and easily broken by oxidative stress. Vitamin C also serves as a potent antioxidant, protecting newly formed collagen from free radical damage during and after synthesis, creating an internal environment where collagen is not only produced, but preserved. When hydration includes this molecular ally, water stops being just a cleansing agent and becomes a collaborator in tissue integrity. This is why the idea of drinking water for skin health must evolve from quantity to composition, from habit to strategy, because the skin does not respond to intention. It responds to chemistry, and chemistry responds to what the bloodstream consistently delivers, moment after moment, cell after cell, fiber after fiber. Shaping the skin not as an aesthetic outcome, but as a biological reflection of internal support and molecular readiness, unfolding quietly beneath the surface, where no mirror can see, but every cell remembers asterisk. Minerals operate in the body with a quiet authority, shaping structure and function without drawing attention to themselves. And nowhere is this more evident than in the architecture of the skin, where firmness and elasticity depend not only on proteins, but on the elemental signals that tell cells how to organize those proteins correctly. Silica, zinc, magnesium, copper, and trace electrolytes are not fillers in nutrition. They are instructions written in elemental form, guiding fibroblasts in how to assemble collagen fibers into resilient networks rather than fragile strands. When water lacks these minerals, it hydrates but does not instruct, passing through tissues. Without leaving behind the information required for structural repair, silica, in particular, acts as a scaffold stabilizer, enhancing collagen cross-linking and improving the density of connective tissue, allowing skin to maintain tension without rigidity. Zinc influences DNA transcription within fibroblasts, regulating the rate at which collagen-producing genes are expressed, while copper supports the enzymes that strengthen collagen and elastin bonds, preventing premature breakdown. Magnesium, often overlooked, controls cellular energy transfer, ensuring fibroblasts have the metabolic capacity to sustain collagen synthesis over time rather than in short, inefficient bursts. When hydration includes mineral presence, osmotic balance at the cellular membrane improves, allowing nutrients to enter cells more efficiently and waste products to exit without stress. This balance reduces low-grade inflammation, a silent disruptor of collagen integrity that accelerates skin aging long before wrinkles appear. Mineral-enriched water also influences how tightly water is held within the dermal matrix, improving turgor and smoothness not by swelling the skin, but by stabilizing the extracellular environment where collagen resides. Modern diets heavily filtered water systems and chronic stress deplete mineral reserves, creating a state where the body has enough fluid but insufficient structure. In this context, adding mineral-rich elements to water, such as natural citrus peel, trace mineral drops, or plant-based infusions, restores hydration as a functional process rather than a mechanical one. Cells do not interpret hydration as volume alone. They interpret it as signal density, and minerals increase that density. Over time, consistent mineral-supported hydration changes how skin ages, slowing the loosening of connective tissue and preserving firmness without artificial intervention. This is not a cosmetic illusion, but a cellular adaptation. Where fibroblasts operate in an environment that supports long-term collagen stability, the skin responds not to excess but to precision, and minerals provide that precision by aligning hydration with biological intelligence. When water carries these elemental guides, it stops being a neutral substance and becomes a structural partner, reinforcing the body's innate capacity to maintain form, strength, and resilience from within, layer by layer, fiber by fiber, in a process that unfolds gradually but decisively as cellular communication improves and connective tissue regains the coherence it was always designed to sustain. Inflammation is not an enemy by design. It is a protective language spoken by the immune system. Yet when that language becomes constant, it quietly dismantles the very structures meant to keep the body resilient, and collagen is among its earliest casualties. Within the skin, chronic low-grade inflammation activates enzymes known as matrix metalloproteinases, molecular scissors that break down collagen fibers faster than fibroblasts can rebuild them, creating a slow erosion that no topical treatment can fully reverse. This process is amplified by oxidative stress, where unstable molecules damage newly formed collagen before it has a chance to integrate into the dermal matrix. Plain water, while essential for dilution and circulation, does little to neutralize these biochemical forces on its own. When hydration lacks antioxidant support, inflammatory signals persist, and collagen degradation becomes the dominant rhythm of skin aging. Polyphenols, naturally occurring compounds found in plants, shift this rhythm by dampening inflammatory pathways and inhibiting collagen-degrading enzymes at the molecular level. When small amounts of these compounds are introduced into water through sources such as citrus bioflavonoids, green tea extracts, or herbal infusions, hydration becomes protective rather than passive. These molecules act as messengers, signaling cells to reduce oxidative output and preserve connective tissue integrity. Blood sugar fluctuations also play a quiet but powerful role in collagen breakdown, as glucose molecules bind to collagen fibers in a process called glycation, making them stiff, brittle, and prone to fracture. Antioxidant-rich hydration helps stabilize metabolic stress responses, reducing the cascade that leads to glycation and premature collagen aging. The skin does not experience inflammation in isolation. It reflects systemic conditions shaped by daily inputs, including what we drink. Polyphenols influence gut microbiota composition, improving intestinal barrier function and reducing the inflammatory load entering circulation, which in turn lowers the biochemical pressure placed on skin collagen. This interconnectedness explains why skin clarity and firmness often improve when internal inflammation is addressed, even without external treatments. Hydration that includes antioxidant compounds also supports endothelial function, improving microcirculation and oxygen delivery to the dermis, where collagen synthesis and repair occur. Better circulation means nutrients arrive efficiently and waste products are removed before they can trigger inflammatory responses. Over time, this creates a tissue environment where collagen is not constantly under threat, allowing the body's natural repair mechanisms to operate without resistance. Aging, in this context, becomes less about inevitable decline and more about cumulative biochemical exposure. When water is paired with plant-derived antioxidants, it becomes a daily intervention that subtly reshapes inflammatory signaling, protecting collagen not through force but through balance. The skin responds to this internal calm by maintaining smoother texture and greater elasticity, reflecting a biological state where repair is prioritized over defense, and where collagen fibers are allowed to mature, strengthen, and endure within a system no longer dominated by silent inflammatory noise that slowly fades as hydration evolves into a carrier of cellular reassurance. Asterisk, the body approaches collagen with a hierarchy of needs, and beauty, as humans define it, sits low on that list. Survival always comes first, and collagen synthesis is allowed to flourish only when the body senses that essential resources are abundant and reliable. Collagen is built from specific amino acids, primarily glycine, proline, and lysine, which form the repeating structure that gives collagen its tensile strength and flexibility. When these amino acids are scarce, the body redirects them toward vital organs, immune responses, and metabolic repair, leaving skin structure undersupported despite adequate hydration. Drinking water alone cannot solve this imbalance because water carries no building blocks, only the medium through which they must travel. When hydration is paired with small bioavailable sources of collagen peptides or amino acid-rich additions, it changes the metabolic context in which fibroblasts operate. These peptides are broken down into absorbable amino acids and short chains that signal the body to upregulate collagen synthesis, not just in the skin but throughout connective tissues. This signaling effect is subtle yet powerful, acting as a biological suggestion rather than a forced command. Glycine plays an additional role beyond structure, supporting detoxification pathways and calming the nervous system, indirectly reducing stress hormones that otherwise suppress collagen production. Proline contributes to cellular energy balance and supports wound repair, while lysine is essential for collagen cross-linking, determining how durable newly formed fibers will be. Without a consistent supply of these amino acids, collagen turnover becomes inefficient, leading to fibers that are thin, loosely organized, and easily degraded. When amino acids are present alongside hydration, they are delivered efficiently to tissues, improving their utilization rather than being oxidized for energy or excreted unused. This is where the timing of intake matters less than consistency, as fibroblasts respond to regular availability rather than occasional abundance. Aging skin often reflects a long-term pattern of amino acid insufficiency rather than an abrupt decline in production capacity. The body continues to produce collagen well into later decades, but it does so conservatively, rationing resources in response to perceived scarcity. By pairing water with collagen-supportive amino acids, hydration becomes anabolic, encouraging the body to invest in structural maintenance rather than conservation. This does not override biology, it reassures it. Over time, this reassurance manifests as improved skin density, smoother texture, and a slower rate of connective tissue thinning. The skin responds not to promises but to patterns, and a steady, pattern of amino acid-supported hydration creates an internal environment where collagen synthesis is no longer treated as optional. In this context, water becomes more than hydration. It becomes a delivery system for structural renewal, aligning fluid balance with the raw materials of resilience, allowing the body to rebuild with quiet confidence rather than reluctant compromise. As cellular priorities gradually shift from mere survival toward sustained structural integrity and long-term tissue coherence. Asterisk. Aging skin is often described as dry, but dryness is only the visible symptom of a deeper issue rooted in cellular communication. Beneath the surface, skin cells are constantly exchanging signals that regulate repair, regeneration, and structural maintenance, and these signals are shaped by the composition of the fluid environment surrounding them. Cells respond not simply to the presence of water, but to osmotic balance, electrolyte gradients, and micronutrient availability, all of which determine how receptors on the cell membrane behave. When hydration lacks electrolytes and signaling molecules, cells struggle to maintain equilibrium, leading to impaired nutrient uptake and inefficient waste removal. This state creates subtle cellular stress that interferes with collagen organization and accelerates matrix breakdown. Electrolytes such as sodium, potassium, and magnesium govern electrical potentials across cell membranes, influencing how signals are transmitted and how enzymes involved in collagen synthesis are activated. When these electrolytes are balanced, fibroblasts function with greater precision, responding appropriately to growth cues, rather than remaining in a defensive or dormant state. Micronutrients further refine this communication by supporting receptor sensitivity and intracellular signaling cascades that guide collagen alignment and renewal. Water enhanced with trace electrolytes and micronutrients improves tissue hydration not by swelling cells, but by optimizing the extracellular matrix where collagen fibers anchor and interact. This optimized environment reduces mechanical stress on collagen, preserving its elasticity and preventing microfractures that eventually surface as wrinkles. Poor signaling also disrupts circadian rhythms at the cellular level, impairing nighttime repair processes when collagen synthesis naturally peaks. Enhanced hydration supports these rhythms by stabilizing intracellular conditions, allowing repair pathways to operate efficiently during rest. The skin, in this sense, is not aging faster because time is passing, but because communication is breaking down. When hydration carries the elements required for signaling, cells regain coherence, responding to damage with repair rather than resignation. Over time, this improved communication slows the loosening of connective tissue and preserves smoothness without artificial intervention. The body is remarkably efficient when signals are clear, and skin aging often reflects signal distortion rather than irreversible decline. By shifting hydration from a simple volume-based habit to a signaling supportive practice, water becomes a medium for cellular dialogue rather than mere transport. This dialogue allows collagen fibers to be laid down with order and maintained with consistency, reinforcing the structural integrity of the skin. The result is not the illusion of youth, but the preservation of biological clarity, where cells understand their role, respond to their environment, and sustain the quiet processes that keep skin firm and smooth. As part of a larger system of internal balance that evolves gently rather than deteriorates abruptly as hydration transforms into a language the body can finally understand. Asterisk.